All right, guys. So it is day 23 in geometry now. It's Thursday, September 11th. Day 23 out of 31 days. And guys, that last week of days, day 28, 29, 30, and 31, that's going to be your finals week. Which when we do finals in this room, what I like to do is on that Monday, we take a practice final and we talk about our options for the final exam. And usually I'll give you a couple of options. You can choose to take a test, or I usually offer a project option, and we'll talk more about that as we get closer to that time. But the point of me saying all of this is next week is the last week of instruction that we have together. The week after that being finals week, it'll kind of just be like a whole week of office hours where you come in, you work on anything that you have left to turn in this class, you work on prepping for the final, you take the final when you're ready, and when you're done, you're basically excused for the rest of the week. So we're really almost done. It's pretty crazy. Goes really fast. But that being said, let's come back to this and take a look at our do now. And this is 4 problems based off of what we learned yesterday about circles. So I wanted to give us a little helpful reminder. In our circle, we know that we have angles that always add up to 360 degrees. That's what's in a full circle, 360. If we see a straight line being formed in the circle, I know that any of the angles on either side add up to 180 degrees. And I know that angles that have the same number of arcs are equal. So we can use all of this information to kind of help us solve little parts at a time in these circles. Okay, and before we start on these, I want to verify every person in the room has this paper. Everybody's got it? Okay, perfect. Okay, so let's all look at number 1. Okay, so for number 1, well, first of all, I'll read the directions to you. Find the measure of the arc or the central angle indicated. Central angles are equal to their arcs. So it really doesn't matter whether we're talking about an arc or a central angle. They got the same measure. Assume that lines which appear to be diameters are actual diameters, meaning those straight lines that go all the way across, the ones that are going to create 180 degrees. So for number 1, I need to find the measure of the arc from K to L. So I'm going to highlight that first. That's what I'm looking for. Here is KL. Does anybody have an idea of what I could do to start solving for anything, or things I might notice that can help me find this measure?
That the 70-degree angle right there is consecutive to the one with the I and J.
With I and J. Oh, yes. This one right here, 70-degree angle, LM. This one is, I think you said consecutive, but I wonder if you're thinking vertical.
Yeah.
Yes, okay, so vertical to IJ. So that means these are equal. Okay, so I know that. So this must also be 70. What else do I know that might help me solve for KL?
KL is 180 degrees, and also the J, I, and M is also the same.
It's a KI and which one?
JIM, if you be at 180 degrees.
Oh, okay, so that right here, mark that. This is a diameter, and so This here is 180 degrees. And this here is also 180 degrees. I probably need one more of my angles to be labeled. What do we notice in the middle of this circle that was given to us? Yeah, there's arcs. These angles all have the same one arc, so they are equal. So I know that JK must also be 70 degrees.
That first one was really bugging me because I did not see the 70 degrees once.
Ah,
So
oh
I
no.
thought I was just looking at the circle that had nothing on it but the letters, and I was like,
It's like,
what
okay,
am I
this
supposed to
isn't
do?
possible. Yes, you would have definitely needed to know that there is a 70 degrees marking here. So if you missed that, that would have made it a little difficult. But now we see it. So I have lots of things marked. Do I have enough information now to solve for KL? What do we think? No? What else would he need? I think we do have enough information. I think we do. Does anybody see what I could do before I tell you?
Probably the way to make it more simple, I would go ahead and add the two, or I would add the 70s together.
Add these.
Add them to, or I would set as an X for the angle or whatever for
Right here.
KL.
Okay, we'll call KLX
And
just
then
to make it simple.
and then I would subtract the combined number of 180.
Yes. You got it. That's exactly what we should do. So what James is saying is basically we have 180 degrees between these three angles, 70, 70, and X are going to add up to 180. So I could take that 180 and whatever 70 plus 70 is, I can subtract it. Whatever's left is going to be X. So let's write an equation just to organize what we're doing here. I know that 70 plus X plus 70 equals 180 because they form a straight line. So let's just write that all out. 70 plus 70 plus X, and you can write those three numbers or terms in any order. It'll work every time. I'll let you take the box. So what would I do from here? Add my like term, 70 plus 70. That will give me 140. Bring down plus X equals 180. And I've just got one more step to solve for X. What would I do next? Yeah, let's subtract that 140 from 180. And we'll get X equals 40 degrees. And remember, we labeled X as KL, so we know now the measure of KL. And it is 40 degrees.
If I would have seen the 70, then I probably would have gotten it. But
Yeah.
I had no clue what to do there because I did not see any numbers.
Yes, that would make it really difficult.
All I saw were the letters, the circle, and then the arches. And I was
Right.
like, well, what's the numbers?
Well, you know, I think it can make it tricky because we've been so used to our angles and our segments being labeled on the inside of the shape. But now we're looking at the outside too because these arcs are the same as our angles. So sometimes they label them on the outside. But Now we know. We got it. So let's look at number 2. Number 2, now I'm looking for an angle. And remember, when we have an angle labeled, the middle letter is naming the vertex, which in this case is our center point. And then the other letters are naming either end of that angle. So IGJ, I'm going to find that on my circle. There's I, there's G, there's J. So this is the angle. That pen is not working. This is the angle we are looking for. Four angles in this circle. What angle do I know?
That J, G, and K are 75 degrees.
Yes, I know that JGK is 75 degrees.
That would also mean that IGH is also 75 degrees.
Oh, good. So IGH is also going to be 75 degrees. Why is that also 75 degrees? There wasn't an arc there.
Be vertical angle.
Yes, because they're vertical angles. Anytime those angles create a perfect X like this, where you have two parts of the circle getting cut in half, the angles across from each other will be equal. So we have 75, we have 75.
And angle IJ and K, that would be equal to 180 degrees, and then also the same for IHK.
Yes, okay, so let me find those letters. I, J, K, this half of the circle, these two angles add up to 180 degrees. And so does the other half. But we could just go ahead and use this to solve, couldn't we?
Yep.
What equation would I write? I know the equation
75
part.
75 plus X.
You said, say it one more time.
75 plus 75 plus X equals 180.
Almost.
Or would it be 360? Because
Mm.
like I did it differently. What I did was I just put, I didn't write an equation. What I did was like 75 equals 150, then 360 minus 150 equals 210, and then 210 divided by 2, which is 105, and get both the halves. So that's what
Yes.
I ended up doing.
That is a great way to do it too. So to slow down what he just told me he did, he saw, okay, well, I know all four angles add up to 360 degrees. Basically, I know that there's two angles here across from each other. We could call those X. So it's like saying I have X plus 75 plus 75 equals, the whole circle is 360. And then if we combine like terms, X and X give us 2X. 75 plus 75, let's see, I should know that, 150. Equal 360. And then those 75s added together making 150, we're going to subtract that from the 360. And whatever's left over is split between the two angles left. So we'll subtract the 150 from both sides. Bring down 2x equals 210. And then we divide by 2. And we get x equals 105 degrees.
It would be faster to You just said 75 plus x is 180, subtract 75 from 180.
Yes, that would be much faster. Absolutely. Both methods work. I want to show the faster method next, though, because that's a great point to bring up. Technically, if you wanted to do it this way, this is valid. You can do this. This works. You get the right number. But there is a quicker way. I see, like we pointed out earlier, that these two angles add up to 180. So we could just completely ignore the other side of the circle and say x plus 75 equals 180. Subtract 75 and you get your answer. X is 105. Both ways work. One way's a lot quicker. So that is number 2. Any questions about that one before we move on? Or does anybody need to copy stuff down? I can wait a minute. Go ahead and move forward then. Okay, so number 3 and 4 are a little trickier because now we have variables. This is like the second class yesterday. So I'm going to zoom in on number 3. Don't let the variables scare you. Remember, they're just values for the angles or the arcs that are given. So for number 3, we're trying to find the measure of the arc from T to U, which is right here. One of the things I like to do whenever we are using lots of different values that have variables in it is to stay organized. I'm going to go ahead and label off to the side that TU is 10x minus 5. This is an optional step, but if it helps you stay organized, do it. Helps me. So I'm going to put that off to the side because I know I'm going to have to use it later. The difference now in number 1 and 2, since we didn't have variables, once we set up our equation and solve, we have our angle. We have our answer. Here, we have to solve for x first. Then we can plug that x in to solve for our missing angle or arc. So.
I think I got it figured out.
You do?
Yeah.
Okay, what'd you do?
I did 10x minus 5 plus 6x plus 7 plus 6 plus 20x plus 6x plus 13 plus 45 equals 36. And I added all the like terms together, and I got 42x plus 66 equals 360, minus 66 on both sides, 294, divided both by 42, and then I got x equals 7, and then I did 10 times 7 minus 5 equals 65, and I've got 65 degrees.
Beautiful. That's perfect. That's perfect. Okay, we're going to slow that explanation down and write out all the steps. Basically, what Brandon just told us is when looking at this circle, the first thing I'm going to notice is I have no diameters. I have no lines that go straight across and cut our circle in half into 180 and 180. The other thing we notice, every other angle and arc has a label on it. There's 10x minus 5, there's 6x plus 7, there's 45, there's 6x plus 13, and there's 6 plus 20x. I know all of these values, and I also know that a circle, all the angles or all of the arcs add up to 360. So we could start to solve for x by just adding everything together and setting it equal to 360. So I'm going to do exactly that. 10x minus 5 plus 6x plus 7 plus 45 plus 6x plus 13 plus 6 plus 20x, this will take up some space. And then I already used 10x minus 5, so I'm at the end. I like to just go around the circle one angle at a time so that I don't accidentally miss any. And we know that's equal to 360 because by definition, that's how many degrees are in a circle. So this looks crazy, but once we combine our like terms, it cleans itself up really quickly.
Yeah. Just to keep it cleaner for me, because when I see a lot of things that overwhelm me,
Right.
I basically went through the circle and added everything through what I could see on the circle, instead of writing everything.
That's smart too.
So instead of having a long line of just numbers all over my page, it's just set to the combination of everything.
Very smart. You can absolutely kind of add them up before you write the problem out. Another way that I like to do it, if you don't want to write it in a big long line, I could stack these so that my like terms are already with each other like this. I could say 10x minus 5, 6x plus 7 plus 45 plus 6x plus 13. So I'm just showing you another way to stack it. Plus 6 plus 20x. So I would need to make sure 20x goes here and 6 goes here. So if you like stacking your terms this way, you could do it that way too. Either way works. I'm going to go ahead and continue with my super long problem since I already wrote it. So what like terms I have looking through here, I'm just going to start with my x's. I've got 10x, 6x, 6x, and 20x. And then we can just start crossing them out as we add them up. I'm going to cross off 10x and 20x, and I know that that is 30x. I've got 6x and 6x, so I know that that's 12x. And I've crossed out all my x's. So then I could say, well, 30x plus 12x is 42x. And now I've got all my x's combined. So then I could go back and look at my regular numbers. Got minus 5 plus 7 plus 45 plus 13 plus 6. So let's see. 45 plus 13 is 58. I'm just crossing things out as I go. I could say 7 plus 6 is 13. I'll just bring down minus 5. So 58 plus 13 is 71 minus 5. When you combine them all, you should get 66. If I did that right. And I've crossed everything out, so I'll just bring down equals 360. Pause here for a moment. I want to see if now that we've got it all set up, maybe you can get to the end of the problem and help me finish this. What would my next step be once I've combined my like terms? You were working hard. I can give you guys a moment.
Minus 66 for both sides of the
Yeah.
66.
Minus 66 on both sides. That leaves me with 42x equals
294.
perfect. And then you're at the very last step.
Divide both of them by 42.
Perfect. Divide both sides by 42.
X equals 7.
X equals 7. Okay, and I would like to have everybody up to the point where we have X solved for, just to make sure we're all there. Does everyone have X solved for? Good. Okay. Once I have my X, what do I do from here?
Replace X with 7.
Replace X with 7. Yes, I'm going back up to my original value. TU is what I need. TU is 10x minus 5. Replace the X with 7. So 10x minus 5, and X is 7. And from here, the work isn't too hard. It's 10 times 7. 70 minus 5, 65. So we will get TU is 65 degrees. There we go. All right, let's look at number 4 now. Right away, I notice that not all of my angles are labeled. So when that's the case, we need to start thinking about relationships that I notice in my circle. Do I have any straight lines? Do I have equal angles? What do I have that can help me solve for X?
23 and then 42. X minus 5.
Yeah, I've got 23x right here for QU, or UQ, which is what I need actually. I'll go ahead and highlight that. UQ is 23x. And then we also know 14x minus 5. What do we know about these two arcs or angles put together?
180.
They equal 180. They're on a straight line. So we can add them together and set them equal to 180. So what equation could I write? Yes, 23x plus 14x minus 5 equals 180. And from here, what would I do next? Combine like terms. Got 23x and 14x. Should give us 37x minus 5 equals 180. Two more steps to go. Now that we're at this point, we'll add 5 to both sides. Going to have 37x equals 185. And then what do I do here?
Divided by 37.
Yes, let's divide by 37.
X equals 5.
X equals 5. Still need to solve for UQ though, right?
Yep.
How do I do that?
23 times 5.
23 times 5, because x is 5. And 23 times 5, let's see. Perfect. You should get UQ is 115 degrees. There you go. That was our do now. Sounds like we feel a little better about what we were doing yesterday. You guys seem to be more confident on this today. That's good. Good. Wonderful. Okay, I'll leave this up for just a moment in case anybody is still copying it down. And if you are done copying it down, let's go ahead and pull out your notes. I would like to teach you one more little thing today.
That's fine. The goofy little thing is what popped up in my mind today.
Just one silly little thing.
Technically, math itself is a theorem.
It really is.
It's a series of equations that just form a bunch of numbers that everyone just has to
Yep.
agree on from what we've been taught. That
Based on rules that we've just made up or some say discovered.
Because who knows?
What was
One
numbers?
plus, one you could somewhere to 15, but we just all agree that it's 2.
Right. Funny how that works.
That's been on my mind this whole morning.
That's- Sometimes you just think. You just think. All right. Did anybody need to see any other of these numbers before we go forward? We got them. Okay. All right. Putting that to the side. Today, I'm going to title my page first. But we've been talking about angles in circles. And now we're going to talk about segments. There are segments, line segments. So I'm going to title this Geometry Unit 4. And today is day 23. It is. Day 23. Nope. And I'll put the date on here too. It is Thursday, bless you, September 11th. So, our title today is Segments in Circles. So, first thing we'll need to do is draw a few circles. So if you want them to look nice, make sure you have a compass. And I need to grab another one because I think I broke mine. Okay, I've got my compass ready. And first thing we want to do is we're actually going to start by titling this as exterior segments, like a subtitle. There's going to be 2 sections. We'll talk about interior next. So first is exterior segments. And we, for exterior segments, need to fit 3 circles side by side. So in order to do that, your circles need to be small enough to have 3 of them fitting. So let me think about this. 1, 2, 3 with this. I have my compass opened up. I'll give you a measurement. I have my compass opened up almost exactly an inch wide. It's a little under an inch, but if you want yours to be similar in size to mine, I'm opening it about an inch. And I'm going to draw 3 circles. Oh no. There's my first circle. Second one will be here. And third one. This turned out all right. I am going to just outline those and make them a little easier to see. Use my pen. Once we have 3 circles, we're going to start adding lines in a very specific way. And I will wait till everybody's got all 3 drawn because you'll want to be careful with where you place your lines for the next part. So whenever you are ready for the lines, just look up at me and I'll know. So the first circle, we are going to draw a line that starts on the inside, right touching the edge of the circle. And that line needs to extend slightly outside of the circle, like this. And then we'll draw another line that also starts somewhere in the middle of that circle, or not the middle, sorry, that edge. And it's going to connect to that line here and create sort of an angle. So it should look something like this. And the way we will label the segments, which in this case, we have 1, 2, 3, 4 segments that are created here. We are going to label these as A, starting on the outside, the top half, this is A. And the next line continuing on A, this segment, is B. Then we go back down under A, this will be C. And inside the circle again, under B, our last one is D. So we have A, B, C, D, and underneath this picture, we will write a little formula. Try to keep the formula just under this circle. So I have A, parentheses, A plus B, close parentheses, equals C times, in parentheses, C plus D, close parentheses. try to make that formula only go with the first picture. Each picture will have a different one. So I may even draw a little line going between the two. Move that one over a little. I'm just being a perfectionist now. Once we have that first circle labeled and our segments labeled and our formula, we're going to do the second circle. This time, again, be very careful with your lines. The first line is going to be just like the first line of the previous circle. Though it doesn't have to go quite as far out. We can make it a little bit shorter. I'm going to go about like this. I'll stop there. You do still want it to extend outside the circle. But then your next line should go touching the outside of the circle. This should not go in the circle at all. We are creating what's called a tangent. A tangent is a line that goes straight off the edge of a circle like this. So in this scenario, we only have 3 segments because this extension coming off the bottom is not a line segment. It's actually a ray. It only has one end that extends forever on only one point, so we can't really measure it. And the way we will label this one is that little segment coming off the top here is A. The segment inside the circle is B. And the other small segment under A is C. And there is no D, just A, B, C. If you have that, we do have another formula. A, parentheses, A plus B, parentheses, equals C squared. So there's our second formula. And finally, our third circle will have 2 tangent lines. So we'll start, nothing should be inside the circle at all for the third one. This one might be a little trickier to draw. A line here. So what goes with your And this one we will be labeling A and A because these are equal. This is the best formula of them all. A equals A. That one's my favorite. Nice and easy. Now, if I zoom out a little bit and start drawing my interior circle, which for interior, there's only one, thankfully, not too much more. Can everybody still see this if you're still copying it down? Okay, perfect. So once you've done your exterior segments, we have just one interior segment circle to draw. Once you get to the interior circle, we're just going to draw 2 line segments inside the circle. Nothing goes outside this time. Start with one that it doesn't have to be perfectly down the middle. That's just kind of where mine ended up. And then we'll do another one somewhere else, making sure that it crosses through the first one. When we label this one, we'll have to be careful as well. So let me just zoom in a little bit. For this one, we will have A, B, C, and D again, but make sure that we start just one line at a time. So A will again be the top shorter segment. B, keep staying on that same line. B goes right here at a lower spot, if that's where you drew your line. Then we go down to the bottom below A. This is C. Keep going, follow that line, D. Something I like to do, this part is entirely optional. I'm going to color code mine a little bit just by highlighting the segments and highlighting the letters that they go with. So I'll make all my A's, E's. E and that's one of my A's. This is a lot to write down, so I will wait a minute and kind of leave this up, make sure everybody's got it copied down. And then we'll also add a formula for the interior segments. This one will be A times B equals C times D. And of course, if any of you feel like you're not a wonderful artiste and you're worried maybe you're copying something down incorrectly, I am always more than happy to make copies of these guides for you guys. So if anybody would like copies of this, I'll actually pause this for a minute. I might make some copies now, just in case anyone wants one now. Okay, so moving to this worksheet that I just handed out to all of you, we are going to start by just looking at each of these problems and talking about which formulas we'll need to use to solve these, because some of them you'll need different formulas. So that's always a great place to start. Figure out what formula you need. So for number one, are these interior segments or exterior segments? Interior, they're all inside. So I know for number one, and well, it looks like all the way up to this whole first page, these are all interior segments. So we can note up here at the top that these will all be interior. And so we will use the interior formula, which is A times B equals C times D. So, one of these on your desk. Once we know which formula we're going to use, the next step would be to figure out and identify what is my A, what is my B, what is my C, what is my D. So we'll zoom in on number one. What I'm going to do is I'm going to start by just picking one line to go off of. I'm going to start with this one. X and 6. I know on here it says that I can start, let me move this, with A and D. So X would be like my A, 6 would be like my B. So I'm going to write the numbers or the values underneath the corresponding part of the formula. X goes under A. Bring down times. 6 would be my B. Bring down my equal. And then I'm just going to highlight my other line in another color. And we'll go from left to right again, C and D, 4 and 9. Okay, so I'll move that to the side. I'm done with it. Now all we got to do is kind of rewrite this in a way that makes a little more sense. Instead of X times 6, I kind of like writing 6X better. So I'm going to do that because that means the same thing. 6X equals. And what would I do for the other side?
36.
36. We're just doing 4 times 9. 4 times 9 is 36. And now our equation has written itself. What do I do to solve for X?
Divide.
Yeah, just divide by 6 on both sides. And we get X equals 6. That's number one. not too bad, is it? Not too bad once you figure out what letters go where. So now that we've run through one together, and I've kind of guided you through it, I would love if any of you could tell me how to set up number 2, keeping in mind that we said everything on this page is an interior segment problem. So we're always going to use A times B equals C times D. So for number 2, what could I write under this formula replacing A, B, C, D? I did. Let's think about it for a minute.
Is it 8 times X and 9 times 16?
Yes, yes, it is. 8 and X are on the same line, so that's my A and B. 8 times X. I could just go ahead and write 8X equals 9 times 16. See what that gives me. I got 144. I'll just bring everything down. What I do from here?
Divided by 8, X equal 18.
Good. Divided by 8. And X equals 18. Good. Thought number 3.
Be 6 times X.
And
That equals to 9 times 10.
Perfect. 6 times X equals 9 times 10. I know 9 times 10 is 90. I'll just go ahead and write that. But above it, I'll put 9 times 10.
X will equal 15. That been divided in both sides by 6.
Yes. You just divide both sides by 6 and you get X is 15. That's pretty good. Okay. I am going to set a timer for 5 minutes. I want you guys to see how many you can finish on this page in 5 minutes. Ready, go. Okay, so let's look at number 4. And what I'm going to do for the rest of this page is I am going to give you the answers. You can check and see how many you got right. And if you got any of them incorrect, I would love for you to tell me so that we can go through that problem together. However, if you all got them all right, I don't want to waste your time going through stuff that you are good on. So, number 4, you should have gotten X equals 5. Number 5, you should have gotten X equals 8. Number 6, you should have gotten X equals 21. Number 7, you should have gotten X equals 8. Number 8, you should have gotten X equals 12. Okay. I'll give answers all the way up to 13 here, or at least the first 10. because we haven't gotten that far yet. If you got to 9, number 9, you should get x equals 10. And number 10, you should have gotten x equals 15. Okay. How did we do? Good, good. How did we do? Did anybody get any of them wrong and maybe want to see any of them worked out? Okay, that is beautiful. I love that. Okay, okay. So, moving on to that back page. Let's take a peek at some of these with variables. Let's take a little peek at it, see what happens. Now, Dustin, can I ask you specifically about these? Because you said you got to 13, right?
Yeah.
You want to tell me about number 11? What did you do here?
You go back to your formulas. You got A times A plus B.
Ooh, yeah, let me get that paper real quick. Where did my formulas go? Oh, here it is. Okay, so this is not an interior angle. Now we've got this one, right? Exterior. I see there's 2 lines inside, there's 2 outside. So we're going to be using this first formula. So I'll go ahead and write that formula down. A times A plus B equals C times C plus D. Okay, so you got your formula. What did you do next?
You plug in the numbers you get here,
Okay.
and
Let's see.
the way I think of it is the one on top or the one that's on this side is the A and B. And this is
Okay, let's see. So are you talking about this or the point?
so the one on the left side of the point. Like
FG?
Yeah.
Okay, so FG is what you're calling A. And what did you call B?
5.
5, the GJ. That is good. We're always going on a continuous line. So I know A is 3, B is 5. So we could start by plugging in our A and B. Let's go ahead and figure out C and D as well. C and D are just the other 2, right? C will be 4. D will be x minus 1. So in my formula, A is 3. I'm going to write a 3 everywhere that I see an A. So 3 outside the parentheses, 3 again inside the parentheses. So we've got 3 times 3 plus our B was 5. Equals. C was 4, so I'll put 4 where C is. Now we have 4 times 4 plus D is x minus 1. Now we have an interesting problem. We're going to have to simplify this equation before we can solve it. So, because I have numbers on the outside of parentheses, remember that means that we're going to distribute. We need to multiply the outside number by each term inside the parentheses for all of them. So the first thing we would do at this step, and before I explain that, is everybody to this point?
Yep.
Okay, so I see 3 on the outside of 3 plus 5. Technically, I could add that first since it's in parentheses and say it's 8. 3 times 8. There you go. You could also distribute and do 3 times 3 is 9 plus 3 times 5 is 15. Add those together. There's multiple ways to do it. I'll do the distribution way just because we're going to have to get used to using distribution, especially for the other half. So 3 times 3 is 9 plus 3 times 5 is 15. And 9 plus 15 is 24. I'll bring down my equal sign. And then we're going to look at the other side. Again, it's distribution. We're multiplying 4 times everything inside. So first I have 4 times 4, which is 16. Then I have 4 times x. What will that be?
4x.
Just 4x. Plus 4x. Then I have 4 times minus 1. What will that be?
-4.
-4. Good. And just like we did on the purple side of my equation, I combined like terms. Do I have like terms on this side?
-4 and 16.
-4 and 16. Good.
12.
Which would be 12. So now I have 4x plus 12. So 24 equals 4x plus 12.
-12 on both sides.
Yes. Now we're solving. -12 on both sides. Write down 12 equals 4x. And instead, you can just divide by 4.
X equals 30.
X equals 3. Okay, now we want to be careful and pay attention to the directions and what the question is asking for. We found X, but it says find DE, which is this segment here. X is 3, but DE,
X minus 1, which
yes.
is 3 minus 1.
Good, it's X minus 1. So now I just got to plug that in. 3 minus 1.
2.
Perfect. 2. So we plugged this in. Now the DE is 2. Very nice. Okay. All right. So there is a little sneak peek into it getting slightly more complicated. But you guys have done some really good work today. I want to say I appreciate you all participating. I appreciate how hard I'm seeing you guys work. And you're all doing wonderful. So that is going to be it today. I will see you guys on Monday. We don't have an exit ticket today. But if you are not sure if you've turned everything in for this week, feel free to come and check with me before you go. You just have, let's see, this week up on the board I have written, it was the practice quiz, day 21 exit ticket and day 22 exit ticket. If you've got all of that turned in, you are free to go. and I hope you have a nice weekend.